What follows is a strategy for ensuring that you have covered all the statements and branches in your code. With modern tools like ECL-EMMA that tell you when you have not achieved 100% coverage, there's less need for this strategy, but it's instructive nonetheless. You start by calculating all the linearly independent paths through your code. You find a linearly independent path by choosing the shortest path through your flow graph that covers a new edge. For example, the first path chosen will pick either edge from the first if statement and will skip the loop. The second path will choose the other edge from that if statement and will also skip the loop. The third path will choose, again, either edge and will go through the loop in the shortest way possible. The shortest way through this loop is to skip the nested if statement. The fourth path will go through one edge of the nested if, and the fifth path will go through the other edge. Together, these paths denote 5 linearly independent paths from the square root function. In white box testing, your goal should be to write enough test cases so that you cover all the linearly independent paths. As mentioned, this is equivalent to achieving 100% statement and branch coverage from a tool like ECL-EMMA. Instead of trying to write test cases that achieve this from scratch, let's go back to the black box test plan we developed in the last video and see how many of these 5 linearly independent paths are covered by those 3 test cases. In the first black box test case, we're looking for the square root of 0. It turns out that that test case covers a relatively short path. The condition in the if statement before the loop is false. We go through the loop, and the condition of the first if statement inside the loop is also false, which means we only go through one iteration of the loop. If you go back and look at the 5 linearly independent paths we came up with in the last slide, you see that this test case completely covers paths 2 and 3. That means there are only 3 paths left to cover. The second test case also takes the false edge of the first if statement. On its first iteration through the loop, it takes the true edge of the outer if statement and the false edge of the inner if statement. I didn't calculate beyond the first iteration of the loop, so it's possible that with subsequent iterations, it will also eventually cover the true edge of the inner if statement. However, even if we just stop at the first iteration, we see that it covers linearly independent paths 2 and 4. Since the first test case also covered path 2, we still need to cover paths 1 and 5. Fortunately, our last test case does this. Unlike the other test cases, it covers the true edge of the initial if statement, which means that path number 1 will be covered. Inside the loop, the first iteration takes the true edge of the outer if statement and the true edge of the inner if statement, and this takes care of path 5. Again, I've only calculated this for the first iteration. It's possible that with enough iterations, this test case will also cover paths 3 and 4. In fact, now that I think about it, every test case will cover path 3. Path 3 is the path through the loop in which the first if statement is false. If you go back and look at the code, this is actually the only way you can break out of the loop. So it turns out that our 3 black box test cases are sufficient to cover all 5 linearly independent paths. In fact, it looks like you would only need test cases 2 and 3 to cover all linearly independent paths, since all test cases must eventually traverse the false edge of that main if statement from the loop. That leads to an interesting question. We started with 3 test cases that cover all linearly independent paths, and then we discover that we can cover all linearly independent paths with only 2 test cases. The question I'm thinking about is, do you think it's theoretically possible to cover all linearly independent paths with just a single test case? please pause the video and try to answer this question. Ready? The answer is no. It is not theoretically possible to cover all linearly independent paths with just a single test case. And the reason has nothing to do with the loop. The reason is that there is no way to cover both the true edge and the false edge of the first if statement, the if statement that is outside of this loop. And that's it for this module on software testing. This is Dr. K. I hope you've learned something, and I'll see you in the next module.